increasing the storage of the computer. The problem they had is they were sequential. You read it, it advances, read it, advance, read and advance. Now, interestingly, we've been writing programs that do this, that everything we've written so far pretty much reads the whole file, reads the whole web page, reads this, everything we read it either a loop or read the whole thing. And that's because we have plenty of memory, but we're still reading sequentially. And so the way you would do this when you didn't have enough spinning storage or online storage is you'd use offline storage, but the trick would be that you would sort it. So let's imagine that you're a bank and you have a bunch of accounts, only a few of which are active on any day, and you have a tape that has, in account number order from low to high, the prior balance, last night's balance of every one of your bank accounts, and then you do all the transactions and you record how much money was taken in or out for each account number, and then you sort those transactions. And then what you do is what we call a sequential master update, and that is you would write a program that would read the first transaction and hold on to it. Say, okay, this is account 45. Then it would read the first account, like 1, and it would copy 1, and then it'd read 2, and read like 7, 8, 42, 43, then it would read like 44, and then it would read 45, but it would change that and write the new 45, and read the next thing, and so this might be 60. And then it would read a bunch of stuff and copy a bunch of stuff, and then it would finally get to 60, and it would merge the add or subtract, and so the old balance ended up here, and the new balance did here, and you had to only make one pass through the data, so it was super efficient. So we had all these mechanisms to sort. We used to do punch cards and have sorters and all these things, and then those things would run for hours. And if you watch old TV shows, these tapes are spinning and these things are running back and forth. These are simply reading and writing tapes, and that's how we did a lot of data processing, because we could store far more on a tape drive than we could on a disk, and with racks of tape drives we could scale the storage that our computers had. And so that's the way we did data processing, but it meant that the only way you knew what the old balance was it was the balance as of this morning before your bank started. You don't know what the balance was for the day, and that led to things like you can never you can never withdraw more than $100 a day or something like that, because you don't know what the old balance was, or you might go withdraw $100 at a couple of different branches, and so they weren't able to look your stuff up right away. Now, it didn't take long until the disk drives got better and better and better, and you could store the entire accounts, all the accounts and their current balances, on computers. And then the problem becomes is what happens if sort of in the middle of the afternoon you want to update a balance? Well, do you want to read all your data and then write a brand new one? And say that takes like 10 minutes. That means for that 10 minutes, only one person can be updating their bank balance. And so because we could randomly access this data, we didn't have to read it all sequentially. The trick is how do you spread the data out, and then how do you make it so you can change a balance? This is of course second nature today, but how do you make it so you change the balance here without changing the balance there, and you can have multiple people going simultaneously to these things, and make sure that you can't say to withdraw money at 2 different locations simultaneously and somehow have your bank balance get corrupted by that. So there's a lot of debate on how to do that, and in early days we just did sequential master update, but increasingly we wanted to make better use of the random nature of our computers and our storage, and so that's what led to databases. Databases are the science of how you make use of rotating random access data, permanent data, in a way that allows you to read, modify, and update that simultaneously from many different locations and yet keep the data completely consistent. And so this led to a study of a thing called relational databases. And relational databases are not the only databases that happened. We had many other kinds of databases, and there was a debate. And I remember in the 70s and the 80s, there was folks that says, oh, no, there you could do index sequential. That's the way to do it. And relational databases weren't all that popular the first time that I saw them. I didn't like relational databases. But relational databases had an inherent advantage because they were based on some really powerful mathematics. And the interesting thing is early on, the relational databases were slower, but eventually they figured out how to sort of bring all the cleverness to bear to make relational databases fast. And so relational databases are a pretty advanced technology, and there are companies like Oracle that are very, very wealthy, and their primary product for many, many years was nothing more than a clever database product, a clever piece of software that was really good at solving this problem. And that's how important this problem was to computing. If you read about databases, you're going to see two sets of terminology. One set of terminology comes from the mathematical background and has to do with the underlying math. Things like relations, tuples, and attributes. That's kind of like the fancy math version of it, and programmers kind of think of them as rows and columns inside of a table. And so if you look at sort of fancy theory, you'll see words that look like this, and they're just full of this and the connection. Now, all this is important and true, and if you really want to get good, you sort of begin to understand the nature that we model data at connections rather than at sort of intersection points, rather than just modeling data as a flat file the way we do. But for now, we're going to, as programmers, think of this as just like, oh, it's like a super fast spreadsheet. The super fast part is the math. For us, the rows, columns, and tables are spreadsheets. So think in a spreadsheet of sheets, sheet, and that's like a table, a named thing like tracks or albums, artists or genres. And then there is rows, and each row has a different kind of data. And then there's columns, and we sort of specialize the first column in many spreadsheets to say what's in there. This is not really the data. This is like metadata. It's like the title's in this first column. That's not really the data, and the data starts here. And we have different kinds of data like strings and numbers, et cetera, for each of the rows. And literally, you can get away with this as sort of about 80% of databases is just a really super cool spreadsheet. But under the covers, it is far more powerful than that. So one of the early arguments that happened was, again, what the programming model for this was. And a lot of folks wanted a programming model that reflected how the data was actually stored. The notion of structured query language came about in a way to express what you wanted to happen and allow that to be sort of a very abstract expression. Select all records that meet this criteria, not read. And so structured query language is not a procedural language. It is a imperative language where you're simply saying what you want, and then somebody writes the loop. The database actually does the loop, but it's a way for you to avoid actually writing the loop. Now that turns out to be the power of databases, because the cleverness in how to write the loop is a way that you would probably never figure out how to be most supremely optimal when it comes to writing the loop, as you'll see toward the end of joining many tables together and selecting and throwing an array and getting down a count or whatever. Someone has figured out how to do that really, really well. So the idea is you would express, we're going to create some data, we're going to retrieve some data, we're going to insert and delete it. Create, read, CRUD, C-R-U-D. Create, read, update, and delete, CRUD. And so that's what this does. It's a language that does this very simply. Now the applications that we're going to use this for are more of a data analysis application. We've been doing data analysis through the whole course. And the kinds of things that we'll see in the remaining chapters is we'll take some raw data file. These might actually come across the network, and we'll write some Python programs to play with that data, parse it, clean it up, make sense of it, and then write it into a database. And this might be a slow process, or this might be really nasty, and this might be a way to have very clean data. And then we'll write another Python program to sort of read through it, and it's all efficient and pretty. And then we can produce files, and maybe we'll visualize it or do further analysis in R, Excel, or a JavaScript visualization framework. And so in this situation, you will be the person who is both sort of writing the programs, database administrator, and you can, using SQLite Browser, play and look at the database kind of in a raw way. And the first part of this, we are mostly going to be using SQLite Browser just to talk straight to a database. Later, we'll write Python programs that read and write data and visualize the data. So this is what we're going to do first, and then second, we're going to do this part right here. That's the second thing we're going to do. Now, another really common use of applications, and something that if you continue learning more about programming, is that you will want to write an online application like Amazon or a company or Twitter that's got a website and it stores dynamic data in databases. And so the picture for that is similar but different than the picture we're going to start out with. And so the way this usually works is that you, the end user, uses a web browser, talks to the application, and the developer writes the application software, and that application software stores its data